Section 2.4, Objective 1, Evaluate a Formula, Part 2. We're going to start off here by going over some definitions that we're going to need for some of the shapes we're going to be working with. Alright, the first one is going to be the perimeter. The perimeter is the sum of the lengths of all the sides of a figure. Next is the area is the amount of space enclosed by a two-dimensional figure measured in square units. That's because it's two-dimensional, this area. Next is the surface area. The surface area of a solid is the sum of the areas of the surfaces of a three-dimensional figure, and that is still measured in square units also, okay? So even though it's a three-dimensional figure, because you're still talking about area, surface area of a three-dimensional figure is still measured in square units. The volume is the amount of space occupied by a figure measured in cubic units. The radius r of a circle is the line segment that extends from the center of the circle to any point on the circle. The diameter of a circle is any line segment that extends from one point on the circle through the center to a second point on the circle. The diameter is 2 times the length of the radius, so therefore d is equal to 2r. In circles, we use the term circumference to mean the perimeter. Alright, now that we went over all those definitions, we're ready to start off here with the shapes. We're going to start off here with plane figure shapes. And what we mean by plane figure shapes or plane figure formulas is we're talking about two-dimensional shapes. So you guys should have these formulas memorized. You're expected to know these formulas when you go on to higher level math. Square. Let's draw a square. Actually, I got a better idea. Let me use this to help me draw a square. How's that? Let's see, does that look like a square right there? Well, you know what? Let me get rid of these lines. There, that looks better. So a square has 4 90-degree angles. When you see this little square shaped here on an angle, that means it's a 90-degree angle. And all 4 sides of a square are equal in measurement. So when I draw this little line on that segment, it means that they're all equal in measurement. Or we could draw a side here, S for side. That variable is going to mean that they all measure the same amount. So if we wanted to find the area of this, the area would be the inside of the space here, what's enclosed, and it's measured in square units. We would just have to multiply S times S, or we could write S squared. If we want to find the perimeter, you just need to add up all 4 sides together. So that would be S plus plus S plus S. Or 4 times s would be a little bit faster. Rectangle. There's my rectangle. Okay, so rectangle, like a square, it has 4 90-degree angles inside. The opposite sides are equal to each other in measurement. So I'm going to draw 2 little lines here and 2 little lines over here to show that these 2 sides are equal to each other. I'm going to call this shorter side width, W for width, and the longer side L for length. Now, that doesn't mean that the longer side always has to be the length. It oftentimes is the length, but it doesn't have to be. The shorter side could be the length, and the longer side could be the width. It's okay. So these are interchangeable. Area. To find area of a rectangle, once again, that's the inside part right here. And if you need to do something to remind you that the area is the inside part, then maybe we could do something like this. You write area on the inside. That might remind you. To find the area, we multiply the length times the width. Length times width. Perimeter. Perimeter, we just add up all 4 sides. So that means there's 2 lengths, so L plus L, and there's 2 widths, so W plus W. Or a faster way of finding perimeter would be 2L plus 2W. Okay. Triangle. Do I see if I have a triangle here? Oh, I do have a triangle here. It's a nice little triangle. There we go. Nice. Nice triangle. Okay. I'm going to draw this dashed line going down from the top to the bottom. I'm going to draw a little square here to show it's perpendicular to the base. We're going to call this dashed line H for height. Bottom, we're going to call it B for base. And I'm just going to call this side A and this side C just to give them a name. Find the area of a triangle. You multiply 1/2 times base times height. Another way that we could write this same formula is base times height divided by 2. They both mean the same thing. To get the perimeter, we just have to add up all 3 sides on the outside, not the H, just A plus B plus C. Trapezoid. Do I have a trapezoid here in my list of shapes? It does not look like I have a trapezoid. I guess I will have to just draw one. Okay. How's that? That's pretty good. This dashed line that I'm drawing right here, which is going to be perpendicular here to the base, we're going to call that H for height. And then we're going to call the top one little b, the bottom one big B for the base. And then we're going to name one side over here A and the other side C. Start off with a formula for area. Formula for area of a trapezoid is going to be 1/2 times H times big B plus little b. Perimeter, we're just going to add up all the sides that are on the outside, not the H, because that's not on the outside. So it'll be A plus B plus C plus big B. Parallelogram. I believe I do have a parallelogram here in my shapes. There we go. That's a pretty good parallelogram. Okay. Once again, you're going to see me draw a dashed line here from the top to the bottom and make it perpendicular to the base. I'm going to call that H. I'm going to call the top and bottom B, B, and then this side A, A. Please take note, I use B, B here on the parallelogram, and its base has always got to be perpendicular to the height. Okay, so my formula here for area is going to just be base times height. Perimeter, we just add up all the sides on the outside, not the height. So that'll be A plus A plus B plus B. Or we could say 2 times A plus 2 times B. Circle. I think I got a circle right here I can use. How's that? That looks pretty good. Okay. So for the circle, we need a center. So that's going to be my center of my circle. If we go from the center out to any point on the circle, that's going to represent our radius. So I'm going to call that R. If we go from one point on the circle through the center to another point on the circle, then that's my diameter. Then I would call this length here D. Okay? So to find the area of a circle, area is going to be equal to pi r squared. Perimeter, well, we don't call it perimeter with the circle. Remember, in our vocabulary or definitions, we said for a circle we call it circumference. So I'm going to make sure I write out that word. Circumference. And that's going to be 2 times pi times r. Or another way to write circumference would be, because remember that 2 times r, that's the same thing as the diameter. So 2 times r is just d. So we could have d times pi, and that would also work. Cube. So the way you draw a cube is you draw a square like this. You copy the square. You put it back here somewhere. And then you connect these corresponding vertices. Oh, maybe I should use the same color here. Oh, maybe I should use some nice straight lines here, like this. Yeah, it looks way better. Amazing. There's your cube. So we're going to call this cube, the sides of it, we're going to call side, side, side. And that represents the length, the width, and the height. But since it's a cube, all of the sides are the same on the cube. So in order to find volume, we are just going to multiply all these three sides together. So that'll be side times side times side. Or we could just write s cubed. Okay. Sorry, just got distracted there a little bit. All right, surface area. Remember, surface area is actually measured in square units, even though this is a three-dimensional shape, because we're basically just talking about the flat areas, the flat sides all around the outside. This area plus this area plus the top area plus the bottom. So you're basically just talking about all the areas being added together. Since there are 6 sides on a cube, all we have to do is multiply 6 times side squared. Side squared represents the area of one side, and since there's 6 sides in total, we just multiply by 6. And then the units would be square units. A rectangular box. I think I can draw a rectangular box. How's that look? That looks pretty good. Connect your corresponding vertices. A vertex is just like the little the point, the little edge. So I'm just connecting those right there. See, these two are corresponding. And then these two go together right here. And then last but not least, these two go together right about there. Perfect. Amazing. All right, let's label these. Length, width, and height. To find the volume of this rectangular box, all we have to do is multiply length times width times height. To find the surface area, we would need to, probably what I'm going to do is to have more space here, so I'm going to write SA, so I have a little bit more space to write. We need to multiply 2 times the length times the width plus 2 times the length times the height plus 2 times the width times the height. Because if you notice, there's 2 of each type of side, right? So if you look here at the front, this area of this rectangle is length times height. But there's 2 sides that look just like that one. The front and the back right here. See? That's why there's 2 of them. So that would be like this middle one right here. 2 times length times height, because there's 2 of them. So each one of those sides has 2. That's why we're just multiplying each one of those by 2. Okay, sphere. Let's see. I think what I can do here for the sphere is I can draw a circle and try to get it to sort of look like a sphere. Okay, let's see if we can pull this off. think we did it. I think that looks like a sphere. Good job. All right, so the sphere, we have a radius there. There's our center, and then there's our radius going out this way. We'll call our radius R. R. Okay, I can't get it to look orange. How do we find the volume of a sphere? Volume of a sphere is just going to be 4/3 times pi times r cubed. And that's going to be measured in cubic units. Next would be surface area. Remember surface area? That's just the area on the outside. It's the flat, like two-dimensional surface. Imagine you're going to wrap this sphere up as a present. It's like a ball you're going to wrap up as a present for somebody, and you need wrapping paper. How much wrapping paper do you need to go perfectly around the outside of this sphere to wrap it perfectly, right? That wrapping paper, if you lay it out flat, it's two-dimensional. That's why surface area is measured in square units. 4 times pi times r squared. Oh, you see, and you notice there? Notice how this one is r squared and this one's r cubed, right? That should give you a nice indicator, a nice hint to remind you, oh yeah, surface area is measured in square units, whereas volume is measured in cubic units. A right circular cylinder. I think we can do this. There is my right circular cylinder. Right circular cylinder, we need to know the radius and we need to know the height. So radius would come out from right there. I'm just going to draw like a little arrow like right here. Call that R. And the height, I'm just going to label it right outside there. That looks pretty good to me. Volume is going to be pi r squared times height. I know what some of you guys are thinking. You're thinking, oh, why is this one squared? Huh? And this one was cubed. And you said volume was in cubic units. Well, it's because this r squared is going to get multiplied with this h, and the units will then get cubed. Don't forget that this one is getting multiplied to an h, whereas the last one wasn't. All right, so it's okay. It's still cubic units for volume here, even though the r is only being squared. Well, no, where did all my stuff go here? R squared. Let's put that back. All right, surface area of a right circular cylinder. Surface area. Just to make sure I have enough space, I'm just going to rewrite it here as SA to make sure I can fit the whole formula in there. So it's going to be 2 pi r squared plus 2 pi r h. Next is our cone. Let's draw the base of the cone first. It looks like a pretty good base. And then We'll draw one line coming up like this, and we'll draw another line coming up like this, and I think that's a pretty good cone right there. Okay, so once again here with the cone, what do we need? We need to know the height, and the height needs to be perpendicular here with the base. So on the base here, I'm going to draw the radius, then draw my little square. So this represents h, this here represents r for the radius. We're only going to write down the formula for volume of a cone. 1/3 times pi times r squared times h. Okay? Pretty good. Pretty good. We did pretty good here. Let's go ahead and do an example here. Example: if the area of a triangle is 66 square inches and the base is 8 inches, find the height of the triangle. Alright, so they're asking for here to find the height of a triangle. And they're giving us all of the information here to help us figure that out using the formula for the area here, because they're giving us area. So they gave us the area, 66 square units. They gave us the base, 8 inches, and we need to find the height. Okay, so we can totally set this up. So this is just as if anyone's a visual learner like me, they need to draw pictures. This is what we got. We got 66 square inches. That's the inside, that's the area. We got the base, 8 inches, and we are looking for the height. So we'll say h. We'll say h question mark. We don't know what it is. Area is equal to 1/2 base times height. I'm going to plug in everything I know. Times 8 and times h. So this is going to give us 66 is equal to 8/2 h. But 8/2 is just the same thing as a 4. If we're solving for h, we just need to divide both sides by 4. So this is going to give us h is equal to 16.5, and because it's a height, it's got to be inches, right? Because they told us everything else was in inches, right? The area was inches squared, the base was inches, height's got to be inches. All right, good stuff. Let's do one more problem. Call this number 3 example. So you have the opportunity to buy an 18-inch, and that symbol right there, that just means inch or inches, pizza at a cost of $16.99, or you can buy a 12-inch pizza at a cost of $9.99. Which is the better buy? You can tell I'm tired because you can see how my handwriting is just getting worse and worse. We can do this though. We can finish this video together. All right. So what we're going to have to do here is we're going to have to find the unit price per square inch for each one of these. I think that looks pretty straight right there. Yeah, it looks pretty straight. Let's do our work for the 18-inch pizza over here. Formula for the area of an 18-inch pizza. Here. Area is equal to pi r squared. 18 inches, when they're telling you that pizza is 18 inches, that's how much it measures all the way across. But we need the radius, so we would need half of that. So in order to get half of that, I'm going to have to divide 18 by 2 to get the radius. 18 divided by 2 is 9. So that's what we're going to use to plug in here for r. So our area will end up being pi times 9 squared. Let's see what we get there. 9 squared is going to give me 81, so I'm going to write the 81 first and then the pi. We're going to have to plug this into our calculators to get an approximation, but not yet. Let's wait until we're ready to do the calculation. Actually, maybe I should try to get my calculator here out. All right. So we are curious about the price per square. Okay, not yet. Inch. So for the 18-inch pizza, we're going to take the price, $16.99, and we're going to divide it by 81 pi inches squared. And that will give us the price per inch. Okay, now let's plug this into the calculator. Let me get the calculator back out here. Let me clear all this stuff here. So we are going to take the price, 1690, oops, 16.99 divided by, I'm going to use some parentheses here to make sure I get this right, 81, and pi, I believe, is going to be right there. Let's see what we get. So that's what I got right there. Let's scoot that over just a tiny bit. Can everyone see that pretty good? So it looks like this, oh no, it disappeared on me. Well, I believe it was 0.066, and we're going to round here up to 8. Let me just double check it here one more time. 0.6676. Yeah, so if I round that 7 up right there, then that'll go up to 8. So we're going to round tenths, hundreds, thousands, 10,000s. We're going to round to the nearest 10,000th. And that should help us out right there to see what the price is per square inch. So it looks like it's going to be this much per square inch. Now let's figure out how much that 12-inch pizza is going to be. Alright, using the same formula, we first have to figure out the area. We're going to, well, remember 12 inches is, that's how much it goes across all the way, but I just want half. So that's going to be 6 inches, so that's going to be my radius. So we're going to have area is equal to pi times 6 squared. So that's going to give me 36, and then I'm going to put the pi here, 36 pi inches squared. That's the area of a 12-inch pizza. But we're curious about the price per square inch. All right. For the 12-inch, it costs $9.99. We're going to take that price and we're going to divide it by the total amount of area. 36 pi inches squared. And let's see what we get. So 999, here we go, divided by, I can't even remember what I said anymore. 36 pi divided by 36 pi. 36 pi, no, that's not what we wanted at all. Go back, go back, delete. There we go. Second pi. Perfect. And now hit enter. So it looks like this one costs a little bit more. So we said we're rounding to the nearest, what was it? Tenths, hundreds, thousands, 10,000s. So it looks like we're going to round here. It's going to be 0.0883. We're going to just keep that the same. We're going to round down because this is a 3 right here next to it. So let's write that down. Oh, and we're talking about money. 0.0883. I hope that's still coming out in the, let me make that a smaller 3, make sure it's coming out there. Per square inch. So looking at this, because normally we just here go to the cents. If we were to round this to the cents place, I can see that this is about 7 cents, and I can see that this one is about 9 cents. So this one looks more expensive, so that's not the better buy. The better buy is the 18-inch one. So that's the one I want to buy. I'm getting more for my money. So the 18-inch pizza is a much better buy. All right, good job. The 18-inch pizza is a better deal because it is cheaper per square inch. Yeah, good. 40 minutes.